We're solving problem 11 from the spring 2021 AMC 12B. Triangle ABC has AB is equal to 13, BC is equal to 14, and AC is 15. Let P be the point on AC such that PC is 10. There are exactly 2 points D and E on line BP such that quadrilaterals ABCD and ABCE are trapezoids. What is the distance DE? So for this problem, to make things a lot simpler, we can utilize applying the Cartesian plane to this drawing. When we apply that, we want to, first thing we can do is, well, we have all these easy variables to set. So from this, we get that A is equal to 5, 12, B is equal to 0, 0, and C equals to 14, 0. This all happens when you set B equal to the origin. And we want to solve for the distance between D and E. So what we want to do is apply the distance formula since that would probably be the easiest thing to do. That's why we set them on the Cartesian plane to get the coordinates. So once we have this, well, let's look at point P over here. We want to determine its coordinates. So it's sitting 10 away from C and 5 away from A. So it's 2/3 the distance of the total distance AC. So if we do 2/3 to the distance to A, the Y is gonna be 2/3 of it, right? What is 2/3 of 12? 8. That is going to be its Y component. 8 is going to be its Y component. And we can likewise do the same thing for X, where we solve that P is equal to, has the points 8, 8. It's then, because we realize now that since we're in the Cartesian plane, we want to start solving for the slopes of all these different segments in order to get an intersection from the slope of line CE to line DE. We find that this whole segment with the points B, P, D, and E, let's just simplify BP. Line BP, after solving, yields, well, it has Y equals X. That is its slope. And since it's coming straight out of the origin, we don't have to add anything or subtract anything since it's linear. And it is linear even if it's not out of the origin. So now we can start finding the intersection between these two lines, CE and AB, or CE and BE. So we know from trapezoidal rules that AB and EC are parallel. That means they must have the same slope. And what is the slope of AB? That's from the point 12/5. So we know that the slope is 12/5. So in a sense, we can write that Y is equal to 12/5 X. But that can't be true because we know it's coming out of the origin. So we still have to accompany from it the distance here. So since it starts at point C, which is this amount of distance away from the origin at point B, we at that point have to subtract some amount of loss to make up for it moving this much on the positive plane. And we end up that this is 168/5. We solve for B, how much you add and how much you compensate for it. So then we have this equation here, and we know the slopes of both of these equations and the equations of both of these lines. So we know the equation of this long line, so we can find the intersection here by basically equating the equations to each other. So from BP, this is x equals 12/5 x minus 168 over 5. This gets canceled out. This is 7/5 x. And then we get that when you remove the 5s from the denominators and shift this term over here, 7x is equal to 168. So x is equal to 24. That's the x component of this point E. Since we know it lies on the line y equals x, E has coordinates 24, 24. We can find coordinates of D, which lies on the same line. Since we know that it's the same height from point A, and A has a y of 12, we know that D has coordinates 12, 12. So we can apply the distance formula to these 2 points. So the distance is equal to, well, when you basically the distance formula is subtracting the y2 from y1, so 24 minus 12 is 12, and then you square and then you square it, and then you do the same for the x. Since they're the same, you just square root it. This is 2 times 2 times 12 squared, so 2 times 144. So we find our DE to be, when you take out the 12 squared out of this equation, you get that our answer is 12 root 2. So the distance we want is 12 root 2.